Hello everyone, welcome to the webinar series of IoT. My name is Malvika Bhardwaj and I am Executive Training with Fice Education. Today's webinar session is based on interfacing techniques with Intel Galileo. So, before going into depth of this webinar session, I would like you to introduce the today webinar topics. So, firstly, in this webinar session, we're going to discuss about the sensors, and next we're going to discuss about sensors and actuators and difference between both of them. And after that, we'll discuss about role of Intel Galileo in sensor interfacing. And after that, we will discuss about the digital sensors and analog sensors and the interfacing with the Intel Galileo Gen 2 board. And at last, we're going to discuss about basics of PWM and its application. So, before moving to the first topic of this webinar session, let us remind the basic specifications of the Intel Galileo Gen 2 board. So, this Intel Galileo Gen 2 board consists of a power supply port. That is, we can power up this board up to the range of 7 volt to the 15 volt. Next, this port consists of input-output jumper. That is, we can set the working voltage of this board either to 3.3 volt or to 5 volt. Next, we have a Quark SoC X1000 processor. This is a 32-bit processor and is a family of low power processors. This processor is ideally used when low power and size takes priority over the high performance. Next, we have a onboard RAM that is 256 MB and also we have a ROM of 8 MB. This board has a dedicated host port which can be used for interface the devices like USB camera, keyboard, mouse. And this board also consists of USB client which is used whenever we want to program this board. And next we have a 6-pin FTDI header on this board which is used to access the Linux. This board also have a Ethernet port which provide the HTTP connections to the Google by using Ethernet libraries. And it also have a micro SD card slot. That means we can insert a SD card on this board which is up to the limit of 32 GB. And also we have a 14 digital pins and 6 analog pins. And also we have a reboot button which is used to reset the whole board. And at last we have a reset button which is used to reset the program on this board. Now we will move to the first topic of this webinar session, that is introduction to the sensor. As we know, sensor is a device that converts physical parameters from external environment into the voltage signal, or we can say that it is a device whose purpose is to detect events or changes which is occurring in its surroundings and then provide a corresponding output voltage. So by this we get to know that input to a sensor is always a physical quantity like temperature, touch, flame, fire, etc. But output of the sensor is always a voltage quantity. So next we will discuss about the transducer. So a transducer is a device that converts one form of energy to another form. A sensor is a transducer, but every transducer is not a sensor. So we can say that a sensor is a subtype of a transducer. And nowadays transducers are employed at the boundaries of automation, measurement and control systems where electrical signals are converted in other physical quantities. Some of the examples of transducers are pressure sensor, which measures pressures of gases or liquids and generate electrical signals corresponding to the input pressure. And another example is antenna. That is, antenna is used to propagate electromagnetic waves to and from to conductive electrical signals. Next, we'll discuss about sensors and actuators. So, as we have already discussed that sensor can be defined as an appliance that detects changes in physical quantities and produces an electrical signal output as an acknowledgement of that change in that specific quantity. So, a sensor sensitivity indicates how much the sensor's output changes and when the input quantity being measured changes. So, next we will discuss about the actuator. So, an actuator is a component of a machine that is responsible for moving or controlling a mechanism or system. An actuator requires a control signal or source of energy. When the control signal is received, the actuator responds by converting the energy into the mechanical motion. Examples of actuators are hydraulic actuator, pneumatic actuator, or electric actuator. The hydraulic actuator consists of a fluid motor that uses hydraulic power to facilitate mechanical operations, and a pneumatic actuator converts energy formed by vacuum or compressed air at high pressure into the rotatory motion. So, we get to know that an actuator outputs output of an actuator is always a mechanical motion. Next we will discuss about the various types of sensors. So on the basis of output of a sensor, the sensors can be divided into two types. First is digital sensor and the second is analog sensor. Digital sensor interacts with physical environment and returns a number 0 or 1, or we can say that a digital sensor is an electronic sensor where data conversion and transmission are done digitally, either 0 or 1. Digital sensors are modern successors of the analog sensors. In digital sensors, the signal measured is directly converted into a digital signal output. Example are touch sensor, digital vibration sensors. And whereas an analog sensor, the sensor that produces continuous analog output signal, and this continuous output signal produced by the analog sensor is proportional to the measurand. Examples are accelerometers, ambient light sensors, temperature sensors. So, ambient light sensors are used for detecting the amount of light striking on the sensor, and whereas accelerometers are the devices that detect changes in position, velocity, and orientation by sensing the motion of the system. Next, we will discuss about role of Galileo in sensor interfacing. So, if we talk about analog and digital pins, so there are 14 digital pins, and out of these 14 digital pins, there are 6 PWM pins, and also we have 6 analog pins. So, by default, these analog pins are input pins, and we cannot write on analog pins because we cannot generate signal on the analog pins. They are unidirectional pins. And in digital pins, we have a sign marked by a tilde sign. So, this tilde sign represents the PWM pins. Now we will discuss about placing a digital sensor using breadboard. So here we are interfacing a digital sensor with the Intel Galileo board with the help of a breadboard. A breadboard is a construction base for prototyping of electronics. The picture shows the connection. In this, a sensor consists of three terminal wires. Black one is used for the ground, red one is the VCC, and the yellow is the output wire or the signal wire of the sensor. So when we connect this sensor to the Galileo board, the ground wire is connected to the ground of the Intel Galileo board, and the red wire, the VCC wire, is connected to the VCC of the Intel Galileo board with the help of breadboard. And, and at last, the yellow wire or the output of the sensor is connected to the digital pin of the Intel Galileo Gen 2 board. And suppose if we are using an analog sensor instead of this digital sensor, so the output of this sensor, that is analog sensor, is interfaced any of the analog pins of the Intel Galileo board instead of the digital pin. And next we have our operations with digital pins. So we have three APIs for the digital sensors. First one is the pin mode. It is used in the void setup and used to configure a digital pin to behave as an input or output. So this pin mode is used to set a digital pin either an output or input. So this pin mode API contains two arguments. The first argument is the pin number, which pin we are going to use, and second argument is the mode, in which mode, either output mode or input mode, that pin is going to be used. So in examples you can see that we are using pin 13 as the output pin. Next API is the digital read pin, and this API is used in void loop, and this API is used to read the value from a pin, digital pin, which is either high or low. So with the help of this API, we can read the value of any digital pin, and this API takes one argument, that is the pin number. And examples you can see that we are using digital read API, and in arguments we have written pin number 13. So in this example it is shown that we are reading the value of pin number 13 and transferring that value into the variable value. And at last we have a digital write API. So this API is also used in void loop, and it is used to write on the digital pins. So we can say that with the help of this API we can write either high or low to any of the digital pins. In examples you can see that digital write is taking two arguments, first one the pin number, and second one which value, either high or low, which we want to give to the pin. So in this example we are giving high value to the pin number 13. So these are the three APIs which are used for the digital pins operations. And next we have taken an example for the digital sensor. So in this example is bank locker security system. So in this we are taking an example of an application, and in this application we are using an PIR sensor in the locker room of a bank. Now what is a PIR sensor? PIR sensor is a passive infrared sensor that measures living objects in its field of view, and PIR sensor is a type of digital sensors. So living objects always radiate some wavelength, and the PIR sensor is tuned to detect the IR wavelength which is radiated from the human bodies. So if a person enters into the locker room at any odd hours, the PIR detects it and alarm will turn on. Next we will learn that how we will interface the PIR sensor to the Intel Galileo Gen 2 board. So in the picture we can see that the PIR sensor consists of three wires. The black one is the ground wire, the red one is the VCC wire, and the yellow one is the output or the signal wire. So in the table you can see that the ground wire of the PIR sensor is connected to the Galileo pin, that is ground pin of the Intel Galileo board. Next, the VCC wire or the VCC terminal of the PIR sensor is connected to the VCC of the Intel Galileo Gen 2 board, and the yellow wire, that is a signal wire, is interfaced with the any of the digital pin of the board, that is pin number 0 to 13. So next we'll discuss the sample code for that application. So in this sample code we are using two digital pins, that is for the LED pin and another is for PIR sensor. So in this sample code I am taking LED pin variable and giving the variable the value 13, that is I am initializing this variable as 13, and next I am initializing PIR sensor variable as 3. Okay, and after that in the void setup I am using the pin mode API twice. So in the first pin mode API I am setting up the LED pin, that is pin number 13, to the output, and next API pin mode API I am setting up the PIR sensor variable, that is pin number 3, as an input pin. So in void setup I am using pin mode twice. In first I am setting LED pin as output and I am setting PIR sensor as input. So in next void loop I am using an if else condition. So in if condition I am checking the value of the PIR sensor with the help of digital read. So if the value of the PIR sensor is high, then I am giving a high to the LED pin, that is pin number 13, with the help of a digital write API. And if the value of the PIR sensor is low, I am writing a low on the LED pin, that is pin number 13, with the help of digital write. So by the help of this sample code we learned that how can we use pin mode, digital read and digital write APIs for writing a code for the digital sensor. Next we will discuss about the analog sensors. So why we use an ADC in analog pins? As I have already mentioned that analog pin have inbuilt ADC. So what is the purpose of using ADC here? The reason is that a microcontroller is a digital electronics device. It can respond to only two states, that is either on or off or high or low. So that's why we use ADC, which converts input from the analog sensor, that is continuous signal, into discrete levels represented by a sequence of digital 0, digit 0 or digit 1. So basically analog pins are nothing but the input of the ADC. So this Intel Galileo Gen 2 board have an inboard ADC which will convert the continuous analog signal to the digital signals. So ADC will map values between 0 to 5 volt into the integer value between 0 to 1023 volts. Now that means the voltage is converted by the ADC into the range of the 0 to 1023. Now the resolution of ADC. The resolution of n-bit analog to digital converter, that is ADC, is a function of how many parts the maximum signal can be divided into. So the formula to calculate resolution is 2 to the power n, and n is the number of either the if we are using a 10-bit ADC, then the value of n will be 10. If we are using 12-bit ADC, then the value of n will be 12. For example, a 10-bit ADC has a resolution of 2 to the power 10, that is 1024. So, if the reference voltage is 5 volt, thus in 10-bit ADC, the resolution will be the maximum voltage, that is 5 volt, divided by maximum limit of the ADC, that is 1024. So the value will be 4.89 millivolt. So the resolution will be 4.89 millivolt, that is around 5 millivolt. Next, we get to know about the interfacing of the analog sensor. So here we are using an temperature sensor, and we are interfacing the temperature sensor to the Intel Galileo Gen 2 board. So by the picture you can see that the temperature sensor consists of 3 terminals. That is, the black one is the ground, the red one is the VCC, and the green one is the output or the signal wire of the sensor. So the black one, that is the ground wire of the sensor, is connected to the ground of the Intel Galileo Gen 2 board, and the red one, that is the VCC, is connected to the VCC of the Intel Galileo Gen 2 board. And at last, the signal wire or the output wire of the sensor is connected to the either of the analog pins of the Intel Galileo Gen 2 board, that is from A0 to A5 pins. Next, we will learn about the APIs of the analog sensor. So in analog sensor, we only use one API because the analog pins are the unidirectional pins, that is, they always used as the input pins. They are not used as the output pins. So we have only one API here, that is analog read API, that is only for the reading of the analog pins. So in this, the analog read API reads the value from an analog pin, that is the pins from 0 to 5, that is pin number 0 to pin number 5, with the help of 10-bit resolution. So in an example, you can see that we are using an analog read API and it takes only one argument, that is the pin number. So we are using an analog read API to read the value of the pin number 0, that is A0 pin of the Intel Galileo Gen 2 board, and we are transferring that value of the sensor to the variable value. Next, we learn about the steps to perform while writing a test case. So in this, we learn about how to interface an analog sensor, or how to code an analog sensor to the Intel Galileo Gen 2 board. In the first step, we initialize the pin. Either it is digital pin or either it is analog pin. We have to initialize them. Either they are used as an input, either they are used as an output with the pin number. So in this, we will set the mode also. The mode will be output or input. And after that, the next step, we will read the value of the sensor. That is, the sensor which is connected to the pin, digital pin or analog pin, we have to read the value of that pin. Okay, and in this, we are reading the sensor value and converting the value to the voltage. That is, the sensor value may be of any volts, and after that, by this formula, sensor multiplied by 5 divided by 1024. By using this formula, we are converting the value of a sensor into the voltage, and after that we are converting the voltage value to corresponding temperature value by dividing voltage by the sensitivity. So temperature value will be voltage value divided by the sensitivity. So sensitivity of every sensor is not same. Different sensor have different sensitivity value. So it will depend upon which sensor we are using. So the sensitivity of the different sensor will be different. And next we'll display the sensor values and the corresponding analog values on the serial monitor. So, and depending upon the sensor values, we will actuate the output device. So, these are the steps which are used to interface an analog sensor to the Intel Galileo Gen 2 board. Next is the sample code. And in this sample code, we have first set up the baud rate by the help of serial.begin API. And after that, in the void setup, we are taking some variables, that is voltage, sensor and Celsius, Fahrenheit. We are taking these four variables and initialize these variables as a zero value. And after that we are using a void loop, and in this first we will read the value of the analog sensor that is connected to the any of the pins of the Intel Galileo Gen 2 board, analog pins of the Intel Galileo Gen 2 board. So this analog read API here reading the value of a sensor that is connected to the pin number 0 of the Intel Galileo Gen 2 board, and we are transferring the analog read value to the variable sensor, and after that we are converting the sensor value to the corresponding voltage with the help of the formula sensor multiplied by 5000 divided by 1024. With the help of this we are converting the sensor value to the corresponding voltage value. And after the next step, after getting the corresponding voltage value, we can convert that voltage value in the Celsius, and after that we can convert this voltage value to the Fahrenheit, and after that we are printing the temperature onto the serial monitor with the help of serial.print API. Same thing, we are printing the value of a temperature that is in Celsius on the serial monitor with the help of serial.print API. And after that we are printing the value of a value of a temperature in Fahrenheit onto the serial monitor with the help of a serial.print API. And next we have a PWM. What is a PWM? PWM stands for pulse width modulation, which used for analog results with the help of digital means. It uses a digital control to create a wave. So what we are doing in PWM, we are using digital pin to control analog signal. So signal switches between on or off to stimulate voltage between 0 to 5 volt. Or we can say that we are simply turning on or off. On is generating 5 volt and off is generating 0 volt. And duration of on is called pulse width. So we are controlling the width of a pulse, and here width is nothing but just on time, that is called duty cycle. And now we will let you know about the applications of PWM. So PWM is used in telecommunications. In telecommunications, PWM is a form of signal modulation where the width of the pulses corresponds to specific data values encoded at the one end and decoded at the another end. And another application is voltage regulator. PWM is also used in efficient voltage regulators by switching voltage to the load with the appropriate duty cycle. The output will approximate a voltage at the desired level. And the next application is audio effects and amplifications. PWM is sometimes used in sound synthesis, in particular subtractive synthesis, as It gives a sound effect similar to the chorus or slightly detuned oscillators played together. And the last application is servo control. Servo control from a radio control receiver to the servos is done by sending each servo a PWM signal, that is pulse width modulation signal, and a series of repeated pulses of variable width. Now we have PWM PIN details. So for the PWM applications, we have only one API, that is analog write API. Analog write API is used to write the value on any of the pins of the PWM. It will take two arguments. First one is the pin number, that is any of the pin of the PWM, and next is the value, which value we are going to give to that pin. So in example you can see that we are using analog write API and we are using pin number 3 and we are giving value 18 to the pin number 3. And at last there is an application of PWM. In this application we are using a servo motor and we are interfacing that servo motor to the Intel Galileo Gen 2 board. So you can see that the ground of the servo motor is connected to the ground of the Intel Galileo board, and the VCC of the servo motor is connected to the VCC of the Intel Galileo board, and signal wire, that is the output wire of the servo motor, is connected to any of the pins of the PWM, that is 3, 5, 6, 9, 10 or 11. So here we can see that the interfacing of the motor. So we have a motor here, and with the help of a breadboard we have connected that motor to the Intel Galileo Gen 2 board. So so uh, so we have some few steps here, that is we have created a servo object and attached the servo object to the pin, and next we are using servo.write API where position is an integer between 0 to 180. So here we are interfacing a servo motor to the Intel Galileo Gen 2 board. And at last there is a sample code that we have used for interfacing a servo motor to the Intel Galileo board. In this, first we are adding a header file, that is servo.h header file, into this code, and at next we have created a servo object myServo, that is a type of servo. Next we have taken a variable pos, and we are initializing this variable as 0, and in voice setup we have used an API, that is myServo.attach to the pin number 9 of the Intel Galileo Gen 2 board. That is we are interfacing a servo motor to the pin number 9 of the Intel Galileo board, and after that we are in void loop we are using a for loop, and in this for loop we are setting up the positions from 0 to 180, and we are incrementing this position one by one, and in this for we are giving these positions to the servo motor with the help of myServo.write API. That means we are giving this position from 0 to 180 to the servo motor, that is in the increasing order, and after that we are giving the positions in decreasing order, that is from 180 to the 180 to the value 1, and from by this the speed of the motor is decreased, and we are giving these values from 180 to the from 1 with the help of API, that is myServo.write API, write API. So with the help of this code we are increasing and decreasing the speed of a servo motor with the help of PWM pins. So You can contact us on Fice for Innovation and Collaborative Education, or you can mail us on info@fice.in or mentor@fice.in. Thank you.